Hey, so we are talking about 4.10 triangle proofs, which we did today. And so this is kind of unlike most of the other lessons where you get the video notes in advance of the lesson. This is the other way around. We did the lesson today, and here are the notes to go with that lesson. All right, so this section here, this pulse check, you're doing that on your own, okay? And this is just going to jog your memory. You have it in 4.9. All you have to do is just try not to copy directly from 4.9. Really just try to recall what it means for these five criteria in terms of the triangles that are involved. So go ahead and mark up the triangles to indicate angle, side angle, or angle, angle, side angle, side, or hypotenuse, leg. Try to figure out how do those look on these triangles using tick marks and arc marks, okay? What's the difference between angle, and angle, angle, side? Okay, what's unique about side, angle, side? And what is HL or hypotenuse leg the exception to? Okay, and if you look at that, it'll give you a clue. All right, so what is it the exception to? And then, of course, what doesn't work and try to recall why. All right, now on to the examples. So let's look at these two examples. It says, can the two triangles be proven congruent? If so, name the shortcut. If they can't, then write none. Okay, so we have this information that we are given, and what I did was I drew two triangles and I labeled them and I marked them accordingly. So it said angle P was congruent to angle M, so I put arc marks at M and P. It said segment MO is congruent to segment PR, so I put a tick mark at segment MO and one tick mark at segment PR. And then it tells us that angle O is congruent to angle R, so I put two arc marks at angle O and two at angle R. And in looking at both of these, there's an angle, a side, and an angle that are congruent. What's unique? The side is in between the two congruent angles. So these two triangles are congruent by the angle, side, angle congruence postulate. Okay, let's try B. So if you take a look at B, B is tricky because it's tempting to just be like, oh look, it's side angle side. But when you take a closer look at the tick marks, what I notice is that we don't see any indication that these two sides are congruent. This side has one tick mark, that one has two. That means that they are of two different measures. Same thing here. So these tick marks just simply mean that these two sides are congruent and these two angles are congruent. So basically it's just telling us that we have a set of isosceles triangles. That's it, right? So these two are congruent and I have an isosceles triangle here. I don't know what the measure of this vertical angle is, so I can't assume that it's the same as these two. I know that if these two sides are congruent, then these two angles are congruent. But other than that, I don't really know anything else. I don't know anything else. So I have two isosceles triangles, but whether or not I can prove that they're congruent, I can't. So this is none, right? I can't use any of those postulates or shortcuts or criteria, none of these, to prove that these two triangles are congruent, okay? So don't be tricked. You really need to look at if corresponding sides have the same number of tick marks, then we can assume that they are congruent. And I want to try that with using actual numbers because sometimes it helps, especially when you get a visual like this one, letter C. So if you look at letter C, we have these two triangles, okay, and it's hard to even separate them into two, but I'm going to use a marker to do that. So I have this triangle here, okay, and I'm going to name that one A, B, C. And then I have this one, this one here. And I'm going to name that one ABC. Let's call it D, B, E. Okay, so I have triangle ABC, ABC, and I have triangle DBE. Okay, and what makes this confusing is that they overlap each other, but they are two individual triangles. The question is, are they congruent to each other? So let's say, well, we know that side BC and side BE are congruent. So let's say that this is 4 units and that's 4 units. Okay, I'm just making up these numbers. And let's say EA is 1 unit. CD is 1 unit. The reason why I am giving these numbers is because the visual is very confusing for me. So I really need to figure out whether or not these sides are congruent to each other. So in this triangle, if we took this side, it's 5 units in length. Okay? And then side BE, and actually what I am going to do is I'm going to just separate them, okay? So let's take side, or rather triangle. It's not the best drawing. We'll call that A, B, C. We said that that's 4. We know that this side, BA, is 5. And we don't know anything about this side right here. But I know that if we have an angle, right, we have this angle here, and this angle is an example of the reflexive property. It is common to both triangles. Okay, so then let's draw the second triangle. And it's not drawn to scale, sorry. We know that these are going to be the same angle measure because this angle B is common to both triangles. So if this is 45, or let's say this looks more like maybe 38. It's 38 in both this triangle ABC and triangle DBE. So we know that the length of BE is 4, and we know that the length of BD is 5, because we gave it those arbitrary numbers. So we can say that side BA is congruent to side BD, and we could say that side BC is congruent to side BE. And therefore, we can prove these congruent by the side angle side congruence postulate. Side angle side, side angle side. Okay, they have this 2 sides in common, and then or that are congruent to each other, and then the angle is smack in the middle of those 2 congruent sides. So that's by the side angle side congruence postulate. Okay, now the reason I went through all of this extra for this is, yet again, looking at it with the visual, me myself would need to do that. If you don't necessarily need to do that, you don't have to give it numbers or anything like that. You can look at the diagram and say, oh, look, these 2 sides are congruent, and then there's an angle here. Fine. This just makes it logically make sense to me. Okay? Letter D. So, in looking at letter D, I identified that we have a pair of vertical angles. That happens anytime 2 lines intersect at a point. And so we do have vertical angles, and then we have a set of sides. But notice that the angles that are congruent are not in between the 2 congruent sides. So we have a side, and an angle, and a side, and an angle. So this is going to be side, angle, right? This is side, angle, or angle, side. They don't work. All right, let's take a look at part 2 of the video. I'm making a second video for this, okay? So click on to part 2 of the video to work through the proofs.